Now we're going to be working with quadratic equations, solving quadratic equations. And there are several methods and techniques for solving quadratic equations. In this first part, we're going to be looking again at factoring. We've already looked at that. However, we'll look at it again. And then use quadratic equations. But first of all, let's talk about a quadratic equation in standard form. So on the variable, and the standard form is the following: something times x squared plus something times x plus a constant equals 0. So when we talk about a quadratic equation in standard form, we mean for one side to be 0, everything to be on the other side, and the highest exponent on the variable is going to be that highest exponent is 2, and so we say this is a quadratic equation as long as the coefficient. So, for example, we may have 0, or we may have equations such as 2x squared minus 9x equals 5. This one would not be in standard form, but it is a quadratic equation. Or perhaps have various techniques for solving the quadratic equations. And so let's first of all list the different methods that we can use for solving these equations, and then we'll look at particularly two of these methods. Methods for solving quadratic equations. You've already practiced. We'll review briefly this one method, but you're already familiar with that. The second method we're going to be using is solving by the square root property. Then we're going to use a technique which is called solving. It's used for solving quadratic equations, although the use of the technique is more for using it in completing the square, developing equations of circles, ellipses. But importantly for this class is quadratic equations. Okay? So, first of all, let's take a look at factoring briefly, and then we're going to be looking at the square root property. For example, suppose that we have 2x squared minus 9x equals 5. One of the first things to do in a quadratic equation is put it in standard form. That means it should be 0. And if we have a quadratic equation, just take a look and see, if possible, should we be able to factor this, then we can quickly solve. If we can factor it, you know that the signs are going to be different, and so this middle term is going to be a difference. So we're going to have a plus and a minus, and it turns out that if we have 2x plus 1 and x minus 5, times a minus 5 is minus 10x, which gives us a difference of minus 9x. 2x times x is the x squared. 1 times minus 5 is the minus 5. So we've succeeded in factoring this equation, but we now use the 0 property, multiplication property, which says if two factors equal 0, then one of those factors has to be 0. So we said each of the factors equal to 0. We solve each of the factors. So for the first factor, we have 2x equals a negative 1, x equals a negative 1/2. For the second factor, if x minus 5 equals 0, then x is equal to 5. We could quickly solve by factoring, and the solution set for this equation then is the set which contains negative 1/2, comma 5. And remember, if you use a solution set then you need to use braces to the terms that are in that solution set, which in this case would be negative 1/2 and 5. All right, now let's use the square root property. That's This is also a very efficient technique. If you can recognize that you can use it, then you can solve an equation quickly. And it hinges on the following property. Notice that if you have x squared, which is equal to a, then what you can do is take the square root of each side of minus the square root of the other side. So over here we'll have x, which is equal plus or minus the square root of a. So if all our variables are within a perfect square, square root of each side, and we have the solutions. But don't forget that it has to be plus or minus the square root of one of the sides. So for example, if we have the equation x squared minus 11 equals 0, here we have all the variables inside the perfect square x squared. So what we'll do is we'll take the 11 to the other. So we have x squared equals 11 by taking minus the square root of the right-hand side. So x then equals plus or minus and minus the square root of 11. Okay? We can extend this property to suppose we have x minus 3, the quantity squared, equals a negative 4. Well, notice that perfect square. So we can take the square root of each side. We'll take the square root of the left-hand side and plus or minus the square root of the right-hand side. And don't worry about the fact that you've got the negative. On the right-hand side, we are going to have plus or minus. That negative inside the radical is an I number, so we have I times the square root of 4, but the square root of 4 is just 2. So on the right-hand side, we're going to have plus or minus 2i. On the left-hand side, we have an x minus 3 when we take the square root of the perfect square. And so now it's just a matter of x then turns out to be a plus 3 plus or minus the square root of plus or minus 2i. Okay, so the solutions then are either x equals 3 plus 2i or x equals 3. The 3 and the 2 cannot be combined because those are not like terms. So we do have one solution 3 plus 2i, the other 3 minus 2i, and you can express those in one compact term, compact way by saying this is 3 plus or minus 2i. Now, what if we have a little more complication yet? So suppose we have the following. Suppose we equals 0. Well, once again, notice that all the variables are within this perfect square here. That means that we can use the square root property because there are no other variables that are floating around. So let's add a plus 4 to both sides. And so we'll have 3 times the quantity x. So we have x plus 1, the quantity squared, equals 4/3. We can now take the square root of each side. So the square root of right-hand side, we're going to have plus or minus the square root of 4/3. Finally, we solve for x. X plus or minus the square root of 4/3. Now, if you try to check your answers in the back of the book, they may have rationalized this radical. And so let's go ahead and do it. So we have x equals minus 1 plus or minus the square root of 4 divided by the square root of 3. To rationalize that, we'll multiply by the square root And so finally we end up with x being equal to minus 1 plus or minus square root of 4 is 2 t. Now, notice that how quick and easy this method is. We started with 3 times this quantity squared minus 4 equals 0. By isolating that perfect square on one side and taking the square root of each side, we were quickly able to solve for x. I've multiplied this out and written it in standard form and then tried to use one of the other methods. But if you can recognize that you can use the square root property, it's recommend that you do that. Okay.